Next up on our list of topics is to talk about probability. Before we get into the actual problems in section 9.6, let's talk a little bit about what probability is, what it represents, and what we're calculating with it. Probability basically boils down to the percent chance of a given event actually occurring. We can compare that based on the number of preferred outcomes to the total number of total outcomes. So, take a hat. There's a hat. I'm going to drop into my hat 1, 2, 3, 4, 5, 6 black markers. Also going to drop in 1 red, 1 blue. Shake the hat. And from the hat, I will draw a marker. Now, since I've dropped in a total of 8 markers, and of those 6 are black, the probability of drawing out a black marker is 6 out of 8. So it's a pretty good probability. Black marker. So the definition then of probability comes down to this. Total number of preferred outcomes to the number of total outcomes. So in the case of our demonstration with the markers, probability of a black marker would be 6 out of 8. Always reduce your fraction, so 3/4, and then be prepared to write your answer as a decimal and as a percentage. So 0.75, which is the same thing as 75%. So 3 out of 4 times when I reach into the hat and randomly pull a marker out, I should, on average, get a black marker, or 0.75, 75% of the time. Probabilities will always range between 0 and 1. Now you can include 0, and you can include 1. P stands for the probability of a given event. 0 means it is impossible. It cannot happen. There is no chance of it. For example, going to the hat example. I've got this lovely little hat. Put that black marker back in there, so I'm back up to 6 out of 8. The probability of drawing a green marker. Not green. Also not black, but not green. In fact, since there are no green markers in here, that probability would be 0. On the other side, 1 indicates a probability that an event that always happens. So, it's guaranteed to happen. Again, to my hat. What is the probability that I will pull a marker? A marker. In fact, 8 out of 8 things in my hat are currently markers. Thus, it's guaranteed to happen every single time. So when we talk about the basics of probability, we're asking ourselves, how many different ways can it happen? How many ways did it happen that I was looking for? And I can write those as a fraction. Let's do one more example for demonstration. I have, in my hands here, organize my hand, 3 beautiful pictures of my daughter, 1 picture of my lovely wife, and my handsome son. So I have 5 pictures that I can shuffle together. Now out of those 5, 3 are my little girl. So if I were to randomly draw 1 picture out of the stack, what is the probability that I'm going to draw a picture of my little girl? Let's clear the board up. Since I'm looking at probability of Kaylee. Since I'm looking at a total of 5 pictures, the total goes on the bottom. Of those, 3 are her. So again, decimal and percentage. It's a 60% chance. 0.6 would be the decimal equivalent, and my radius fraction is 3 out of 5. So if I were to take my deck and randomly draw a picture, lovely wife, not little girl, which is also going to happen. Now, there's one other thing we need to talk about, and that's the probability of not having an event happen. The event's complement. So, sticking with our pictures example, the probability of an event not happening so the probability that I'm going to draw a picture that's not Kaylee is the probability of drawing her subtracted from 1. Think of it this way. There are 5 cards. 3 of them are Kaylee. How many are not Kaylee? Well, take 3 away from that 5, that leaves 2 out of the 5. Now I can apply this logic all down the line. If the probability I knew was 60%, that means the probability of it not happening is going to have to be 40%. It's going to have to match up. So again, taking my stack of cards, if I were to talk about the probability of not drawing a picture of Kaylee out of the deck, the picture of Kaylee, it would be 40% of the time. It's going to happen, but it's not as likely. On any given draw of the picture, I'm more likely to get a picture of Kaylee than I am of not getting her. What we're going to be looking at next is what happens when I'm not dealing with actually discrete items, but we're dealing with things on a continuum. And that is the meat and potatoes of our section.